Good evening, students. Today I want to discuss about the concept called tautology in discrete mathematics. So, what is meant by tautology? So, tautology is nothing but the last column of the truth table contains all truths. Last column of the truth table contains all truths is known as tautology. The last column of the truth table contains all truths, or we can also say that it is. Okay, it is known as tautology. For example, P and Q implies PRQ. So whether this is tautology or not. So now we want to check in what manner we need to check is by using a truth table whether this expression is true or not. Okay, the last column contains all truths or not. Okay, and before writing the truth table, observe that in this statement, in this expression, how many statements are available. So here one is P and other one is a Q, right? There are two types of statements. If one statement is there, we can get the truth values are 2, that is either true or false. If there are two statements, then we can get the possible order pairs as 2 power 2 means 4. So we will get the 4 truth values. So what are they? Either both values are true, both values are false, either one is true, one false, or one false and one true. These are the 4 possible truth values. So by using this way, whenever there are two statements, we need to write the truth table like this. Okay. So identify this. First write down the P values and the next Q values. So what are the possible order pairs? Already I told you, right? True true, true false, false true, false false. Okay, in this way we are writing the truth values for the two statements, and then based on the expression we need to take the partitions, right? So first we need to calculate P and Q. So what is meant by and? All these are the connectives, and thereafter we have to calculate PRQ, and finally we need to produce P and Q implies PRQ, right? So this is the truth table. So we need to find out the truth table like this. Okay. So find out P and Q. P and Q is nothing but it is a connective between two statements. If both and means both values are true, the resultant is true. If both P and Q are true, the resultant is true. In the similar way, R means both values are false. P is false, Q is false, the resultant is false. Okay, by using these two, and also we have implication symbol is also there. In that implication, first value true and the second statement, first statement is true, second statement is false, then the resultant is false. Okay, now these are the connectives, and few more connectives also available, but in this expression we have only received and, or, and implies. These three are the symbols, right? So by using these three we can get the truth table. So observe that in the P and Q statement, so PQ statements are having in the first column, right? In the first row we are getting both values are true, then the resultant is true, otherwise remaining are false, right? If both values are true, then resultant is true, remaining are false. This is AND connection. And next one is PRQ. PRQ is nothing but both values are false. So observe that in the above table, both values false are available in the last row, right? So there we are producing the result as false. Remaining are all truths. Okay, now remaining are all truths. And then by using P and Q, PRQ, we are providing an implication. Okay, we are providing the implication between P and Q and PRQ. So in this table, so observe that is there any value which is true value? So in the P and Q we need to find out the true value. So in the P and Q we have only one true value, and there immediately if we are getting false, then the resultant is false. But here we didn't get any false value in the PRQ. When P and Q is true, there is no false statement available in the PRQ. Okay, now if it is there, then only we are getting F, otherwise all are trues. I already told you that what is meant by tautology. The last column of the truth table contains all truths, right? So we observe that by using this table, we observe that the last column of the truth table contains all truths. Hence it is tautology. So in your exams also, they will give one expression and simply they will give verify whether it is tautology or contradiction. Okay, now. So this is the example of tautology. Okay. In the similar way, we have one more example, that is P and Q are R. By implies P and Q are P and Q are P and R. So this is also one of the example for the tautology. P and Q are R by implies P and Q are P and R. So observe that before writing any truth table, observe that how many statements are available. So here we have three statements. One is a P and Q and R. There are three statements, right? So if there are three statements, then how many possible truth values will appear? That is 2 power 3, means 8 possible order pairs. So we can write like this. So in the above table we observe that there are 4 statements. 4 statements, out of 4, 2 are trues, 2 are false. In the similar way, if it is an 8 possible order pairs, 8 possible order pairs, then we can write 4 trues, 4 false, and then 2 trues, 2 false, 2 trues, 2 false. 2 trues, 2 false, false. And the last R statement will be 1 true, 1 false, 1 true, 1 false. Likewise, we need to write all the truth values. Okay. So for this example, we need to write P, Q, R are the statements. 4 trues, 4 false, and then 2 trues, 2 false, 2 trues, 2 false, and next 1 true, 1 false, 1 true, 1 false, 1 true, 1 false, likewise. So in this manner we need to write the order pair. Okay, order the truth values. And next, so first of all we have to evaluate by using a parenthesis, right? Not using parenthesis, we have to evaluate from left to right in this first preference for parenthesis. So first calculate the QRR. What is meant by QRR? R means if both values are false, then the resultant is false. Observe that out of Q and R, where we are getting both values are false, in the fourth statement we are getting false, and the last statement we are getting false. Remaining are all trues. And then calculate the left hand side P and QRR. P and QRR means take P and QRR. So both values are true, then the resultant is true. So on the top we are getting 3 trues, and there TF. So here it is F, and remaining are all F. Why? Because in trues are available in QRR, but trues are not available in P. Okay, now. So this is P and QRR. Coming to the right side, so assume that it is LHS. And right side P and Q. So what is meant by P and Q? Both values are true, then resultant is true. So here we can observe that on the top we are getting 2 trues. And is there any another trues are available? No. Remaining are all false. Okay, now. And similar way P and R. So what is meant by P and R? In the first statement true, P value true, R value true. Okay, and the second statement is not trues. Third statements both are trues. Fourth statement not trues. P and R and remaining. So no other true statements are there. So simply all are false. And find in between P and Q. So it is not having enough space for me to write this. P and Q or P and R. Okay, P and Q or P and R. So here we can write like this: P and Q or P and R. So in between these two we need to replace a false. False means here we are getting F, all are false, and only three truths. One, two, three, four, five. Five false and remaining all are truths. And finally, this is LHS. Assume that it is RHS, and finally LHS by implies RHS. LHS by implies RHS. By implies means if both values are true, both values are false, the resultant is. By implies is both values are true, the resultant is true, both values are false, the resultant is false. Okay, now this is the by conditional, or also called as a by implies. So now observe that P and Q are truth values. Top three truths are there, and here RH side also top three truths. So 3 truths, and remaining 5 are false, and the RH side also remaining 5 are false. Then if both values are false, the resultant is if both values are false, the resultant is true. Okay, both values true, the resultant is true. Both values are false, the resultant is true. So here also same, all are trues. 1, 2, 3, 4, 1, 2, 3, 4. 8 possible order pairs are came. So now by using this table, the last column of the truth table contains all truths. So it is tautology. Hence P and Q are R by implies P and Q are P and R is tautology. So in this manner we need to write in the final exam. The last statement should be, so P and Q are R by implies P and Q are P and R is tautology. Thank you.